Today we're going to be talking about blockchain. Big surprise, right? So I changed my presentation up a bit. I had a big in-depth talk going into the deep weeds about certain things about the tech. But after hearing a couple of the talks today, I think it's really important that we discuss where we're at as an industry, right? Or where we've been, where we're at right now, where we're going. So blockchain today, up till now, if we talk about the past of the industry, in 2008, when this industry really kicked off for the first public blockchain with Bitcoin, it came as a real problem-solving time in the industry. Traditional finance had just been wrecked. Blockchain had been studied for computer science for 20 plus years, and there was a first public use case for it, which was creating a currency that was decentralized, censorship-resistant, and really powerful. Since then, there was a new introduction of something called Ethereum, which introduced this idea of programmability on top of blockchains, smart contracts, applications that leveraged all these different attributes. And since then, what we've seen is once folks actually start using these applications, they become very slow, clunky, and hard to use. So where we are today is a point in the industry where everyone is trying to come up with a solution for solving for the problems that were initially introduced by the scale with Ethereum. So that's why a lot of the talks today you've seen have been from platforms like Layer 2s or Appchain as a service providers or everyone else who's trying to create more and more block space to be able to make applications within blockchain and crypto scale. And now where we've been at this point in time is we have way more than enough block space than we need. So many different types of applications, so many different types of platforms that we can all build on that all leverage different kinds of blockchain tech. And what we really haven't seen, though, in this industry is folks using this tech to put it into the hands of the consumers, to really leverage the tech for other than building more and more infrastructure. At the end of the day, this industry is very technical and very research-based, and it was born out of research labs and research papers. But now we're at a point in this industry where we are beyond that, and we can actually get into more of the application level building. So as I start to get into things related to Avalanche and the technical side, and now I'm going to get into more of the technical details of what we provide, you'll be able to keep in mind that at the end of the day, this is another solution of many that are present within the industry for scaling. So at the base layer of everything in a blockchain, we start with the consensus mechanism. At the end of the day, what is a blockchain? A blockchain is a database, a ledger, that is secured by thousands and thousands of computers within a network. When you're securing all these computers within a network, you introduce really cool attributes to a database. You actually introduce things like censorship resistance, public ownership, transparency, and all kinds of other really important attributes that this industry was started for. Blockchain has been, and consensus have been studied in computer science for 20 plus years. We were introduced to something called classical consensus in the 1970s, which is a traditional form of getting computers to agree upon information. And in this, it's really efficient. It's actually one of the most efficient consensus mechanisms there is. But the problem with classical consensus is that it doesn't scale well beyond 10, 15, 20, 100 nodes within the network. So when Bitcoin was introduced to us in 2008, they realized that to have a public chain, to have a chain that is scaling to thousands and thousands of validators, having multiple people participating in this network, having multiple people validate this network, they realized that the need was very key to create a new consensus mechanism that could scale beyond 100 validators. But the problem is, what we realize is that when you scale beyond 100 validators, it becomes very hard to coordinate those validators on information within a blockchain-based environment. So both of these were two of the biggest innovations that we've had within our industry. Classical consensus being able to showcase how powerful it is to get computers to agree upon information in a really permissioned environment. Nakamoto consensus showcasing what you can do when you scale beyond 100 participants within the network. And then in 2018, after the Ethereum first boom and we started seeing applications form on Ethereum, similar problem because it utilizes Nakamoto consensus as well. Avalanche consensus was born. So Avalanche consensus actually comes from an academic research background. Our CEO was a professor at Cornell for 20 plus years studying computer science and distributed systems, one of the most cited professors within the industry. And him and his two master's PhD students built this thing called Avalanche consensus. They had essentially seen classical consensus, which they had been studying in their classes since they'd been in the industry, and then they saw Nakamoto consensus be introduced in 2009 and said, how could we create a consensus mechanism that could scale to thousands and thousands of network participants while being able to maintain lots and lots of efficiency, such as being able to finalize transactions in under 2 seconds. So that's where Avalanche Consensus was born. It's one of the most powerful consensus mechanisms in the industry, and on top of that, we built the Avalanche network. Within the Avalanche network, originally, there was composed of 3 main blockchains that we built, and we called this the Avalanche Primary Network. What's really important is that within these 3 blockchains, there's one blockchain that controls all these validators that we have that are coordinating and validating all these different transactions. We also have an EVM-compatible blockchain that we launched initially that we threw on top of our consensus mechanism to showcase the power of what you can do to the EVM when you put it on top of a robust consensus. And what that did was it created an EVM environment where you could finalize transactions in under 2 seconds, which really isn't present on the EVM today. Traditionally, on many EVM blockchains, it takes almost 7 to 10 minutes for a block to finalize. As well, on layer 2 environments, it can take up to 7 days for your transaction to finalize. Here, in an EVM environment, your transaction can finalize under 2 seconds. And so, with that, these were the blockchains that we built. These 3 blockchains were the 3 that we built. And because the consensus mechanism is so open, so scalable, and so custom to what you want it to be built like, we allow you to build your own blockchain as well. At the end of the day, we view this as our main value add, where you can come to Avalanche and launch your own custom blockchain, and custom at every layer. So you can take full control of your validator sets. You can take full control of what virtual machine that you have running on top of this blockchain, and you can take full control of who gets to transact on your network, who gets to validate your network, which really puts security into your hands versus into the hands of the public network. So what this gives you is the ability to create fully permissioned, private, enterprise-level blockchains. At the same time, it gives you the ability to create fully permissionless, public, and decentralized blockchains as well. And so what we've seen with that is that folks will really take this stack, because again, it's built on top of a very open and new consensus mechanism, and launch very custom things on top of it. So what we've seen is custom gas fee structures associated with subnets, virtual machines that are non-EVM. So at the end of the day, you can view Avalanche as a playground to launch any blockchain that you'd like. We have many folks that are fan of alternative virtual machines that have seen blockchains succeed on other networks, such as the Move virtual machine succeeding in the hands of Sui or Aptos. But maybe there are some technical limitations that may be present with other networks. So for teams that enjoy other virtual machines, they can come to Avalanche and launch those virtual machines here. So what we saw is we actually saw one team, the Movement team, who was actually up here earlier today, that took the Move virtual machine. They were big fans of Aptos, big fans of Sui, big fans of that development experience using Move, but really weren't losing track at that consensus layer, losing track on the developer experience when it comes to transaction finality and scale. So once they took their Move virtual machine and launched it as an Avalanche subnet, they were able to see a lot of key benefits that they wouldn't have seen otherwise. And so that you can really do with many other virtual machines. You can do that with the Solana virtual machine. You can do that with the EVM and modify it even more using EVM stateful precompiles. And really, at the end of the day, the whole point of this is to say you have a fully custom blockchain that is completely yours to do whatever you would like with it. A little bit of examples regarding subnet architecture. Because of it being a completely brand new blockchain that is spun up from scratch, you're going to need a lot of existing infrastructure such as RPCs, oracles, custodians, explorers, etc. And once you have that, you have all these different layers of the network available to you. So these are all in your control at the end of the day, where you are launching an app chain in other environments. You don't have control of your validator nodes to a full extent like you do here. You don't have the ability to modify the EVM through stateful precompiles, which is present on the EVM on Avalanche. And you also get to have, of course, full control of the application layer as well. And with this, we also have something called Avalanche Warp Messaging, which allows you to be able to transfer assets between subnet to subnet, from blockchain to blockchain. So if you are on one particular blockchain and you want to be able to transfer assets between another blockchain, you have the ability to do that. And you have the ability to permission those validators to accept messages from certain subnets or not. So this is a really cool example of seeing this in action, where if we give the example of traditional finance, where if we have 3 different banks who all individually run a blockchain, they could have multiple blockchains running within each one of their subnets. For example, like if we give bank 1 a name and we say they have both the USD USD chain and GBP chain, and they want to be able to transact with another bank in a different jurisdiction that uses different currency, using AWM, using the blockchain, and using permission validator sets, they'd be able to transfer assets between jurisdictions and between banks almost instantly. It's another really cool graph here to explain that illustrative example there. And so, in addition with this, a lot of developers, what we see are application level developers that may want to run their own blockchain when they start to see scale or when they really start to realize this customizability aspect being a key part of their building process. So what we realize is that many application level developers do not want to be infrastructure level developers. And so we have a whole functionality within our company called Ava Studios, which takes a lot of the infrastructure level work out of your hands. You get to have a fully managed service, which takes nodes, RPCs, a lot of the indexing, and takes out all of your hands, and we handle that for you while you focus on building your application. And so these are just a couple of some of the names within the industry that have been working with us, some ones that I'm sure a lot of you guys recognize. At the end of the day, Avalanche has been within the ecosystem for about 5+ years now, and we work with almost everybody in the industry. But what's really more interesting is the folks who are using the technology, again, for consumer use cases. Now, when I started this talk, I really pointed out the fact that what we've seen is a huge influx of infrastructure-level developers, folks who are focusing on solving issues for problems that sometimes maybe don't exist, right? What we really focus here at Ava Labs is pushing forward this tech and this level of customization and the benefits that blockchain provides into the hands of real users, real institutions, and real enterprises who want to use this tech for whatever reason that they see that benefits them. So we have a number of different traditional Web 2 corporations and enterprises and institutions that have been working with us to bring blockchain into the hands of their users for whatever use case they'd like. And at the end of the day, they do this on Avalanche because of a lot of the technical benefits that I illustrated. At the end of the day, you're building things that are open systems, and what that means is that you want to be able to allow for people to build fully permissioned networks the same way that you want them to be building fully permissionless networks as well. And when major corporations and enterprises are met with this kind of functionality, they really jump at it because they are no strangers to blockchain. They've been using things like Hyperledger fabrics and quorums for years and years, but they've never been able to gain this level of customizability on a blockchain level when it comes to public networks. And that things like embedded user permissioning, having full control of your validator sets, being able to select custom virtual machines, and being able to take gas out of the equation as well if they'd like. So these are a couple of different really cool use cases that some of our folks who are building blockchains within us are utilizing them for. So for example, we've seen the Lemonade Foundation, they built something called parametric insurance, which is really interesting, being able to showcase how they're able to redistribute insurance rewards back to real-world farmers who are present within the real world. SK Planet, which is one of the major conglomerates in Korea, they also built something called UPTN, which is their own blockchain on an Avalanche subnet, which serves as their foundation for their loyalty program that they're starting, which is basically redistributing points back to their users using blockchain and using this unique platform that they've created. And so then we have a couple of other folks within our ecosystem on the institutional finance side that are really doing some really interesting things, because at the end of the day, like I mentioned earlier, fully customizable blockchain, which leads them to being able to take full control of their assets and utilize them in a different way that they'd like. So tokenization has been a big part of the industry very recently. A lot of big narratives have been spinning around tokenization. So we've been in this game for a while. We actually launched our own blockchain subnet, which is called Spruce, and this subnet is actually fully permissioned out of the box. We've set it up to be fully KYC, AML compliant, where any institution or financial big bank or anyone of that nature that wants to test blockchain or test the EVM, they can do so in a very permissioned and safe environment on Avalanche Spruce, so that they know that whatever they're doing is going to be fully legal and compliant to their LPs. And so you can see a couple of the names that are present there who are participating in this program. And these are some of the other things that I'm really interested in as well. For example, like Remedy, they're doing some really cool decentralized science stuff on their own blockchain, where they're basically being able to securely connect to healthcare databases. If anyone's familiar with the healthcare industry, it's actually one of the most corrupt industries there is when it comes to healthcare data and being put into the hands and getting that data sold and things of that nature. So there's some really cool use cases, again, of the technology. And at the end of the day, what we're here to do as blockchains, as infrastructure level providers, is bring these use cases to the hands of users and incentivize people to build these use cases. Because at the end of the day, what we're looking for is developers who want to utilize blockchain for a certain use case versus what we've seen has been traditionally solving problems that sometimes don't exist, right? So we're looking for problems to solve that this technology can actually solve, and we're putting the tech into hands of corporations, enterprises, institutions, and developers who want to solve these problems as well. So yeah, that's the end of the talk. I'll leave some time for questions if anyone has any. Yep, sure. Great question. So some of the subnets that I'm most excited about this year, I think for me, I have a couple of different areas of interest. So for me, I come from an engineering background, so I really love seeing really high tech, high innovative engineering, different projects that are really cool. So for example, we have the movement team that was up here multiple times today. They're building a move-based subnet on Avalanche. I would love to see that launch and actually see a different virtual machines transactions run on top of our consensus mechanism. I think that's going to be really cool. Also, on the consumer side, I know gaming has been a big focus for us. So Beam and Shrapnel and things of that nature are really exciting. And then I know we have some on the financial side that are powering things like, again, the institutional finance side that I really enjoy as well. So, yeah, if no one has any other questions, thank you so much, and I'll be around.